Hello everyone. So in this session we will be learning how to add a tool center point. So for that let's open the Robot Studio and we will start with solution with a virtual controller, and we will select the robot IRB 1200, the 5 kg variant, and create it. Let's wait until the controller loads completely. So we will select one of the library. Okay, now you can see the robot that we have in our lab. So we will attach a end effector to this and create the tool center point for that end effector. So basically tool center point will take the tip of the robot or the tool coordinate. It will define the tool coordinate system for this robot. So for that let's go to import library, equipment, and then under tools you see we will select bin cell ID 22. So when we select the bin cell ID 22, it will by default appear in the base station or base coordinate. So you can select the bin cell ID from here, right click, and then we will attach it to the IRB 220 probe 1. Yes, we want to update the position. So now you can see the end effector, it is attached to this. So when once the end effector is attached to it, we want to create the tool coordinate for this. So for that let's import something more. So go to equipment and let's import the propeller table. So we have the propeller table here. So like we saw in the previous video, we will select or we will modify the position from 4 directions to the same tip of the propeller table, so that we can define the tool coordinate for this end effector. So let's go to controller and start the flex pendant. See, flex pendant. Okay, let's close the default window, and to add a tool center point, we have to go to the Windows menu and then go to program data. So in the program data you see tool data. Select the tool data, and then by default we will have one tool called tool 0, but now we will be adding a new tool. It says functionality is disabled when robot is in automatic mode. Sorry, I forgot to switch the robot into manual mode. So we can select the robot to manual mode. Now the mode is in manual, and let's add new. So new tool is tool 1, or we can say anything. I will tool, and we can add the initial value to it. So while adding the initial value, we might also want to select the mass. Generally the mass is the mass that we expect our end effector to carry. So in terms of gripper, it has to carry some load, so we have to define the mass that we expect our end effector to carry. But this is just a welding tool, so it will not have that much mass, so we will just add 0.5. it should have some positive value, otherwise it will give us some issue. So let's say okay, and okay. Now we can see we have two tools, one is tool 0 and weld tool, and let's select the weld tool and press edit, and we will click on define. So we can select by which method we want to define the TCP. So for now we will just use TCP default orientation, and the number of points we want is 4. We can select number of points from 3 to 9, but we can, for this session we will just use 4, because using 4 is enough for our case right now. So now what we have to do is we have to jog our robot, and just we have to put the tip of the robot to the tip of the propeller table. So let's move. So right now it's in axis mode. Let's move to Cartesian mode and then jog the robot in X. So it's not moving because you can see the guard is stopped, so we cannot move. So we have to enable the motors. So now the motors are on, so we can jog. So let's jog right here. So this Z. It says robot is too close to singularity. Whenever you encounter any error message, we have to acknowledge it. So we acknowledge and then we will try to move. So it's close to singularity, that means we cannot move it in this direction. Axis 1 2 3. Let's move the third. Okay, so we can select first point as this one. See, it's not exactly accurate, but it's quite close. So the when the robot calculates the TCP for this point, it will not be 100% accurate, but we will try to make it as precise as possible. So once we have selected first point, we will select go to point 1 and click modify position. So for the next one, we will change the orientation of the end effector and again bring the tip of the end effector to the same position. For that, let's move our word and let me see. Let's see if we can bring something like this or not. Close to singularity means it cannot go further than this. try to bring it more below. Okay, let's say this is our second point. So we go to the second point and modify position. So likewise for position 3 and position 4 we can add the position. So I will try to do that quickly here. Let's try to bring it from this direction. So let's say this is the third point. 1 3 modify position, and for the fourth position I'll try to do something like this. So okay, this can be our fourth point. So we will modify position, and after we modified all the 4 points we will click OK. So this calculates the end of the tool and it is defined as the weld tool. So this is why how we defined a new tool coordinate for the welding tip. So let's see what we did is correct or not. So we can check just using the, let's go to jogging and select the tool as, okay, let's see. So you have to go to jogging and under the tool select the tool that we created, the weld tool. So you can see the tool we have selected is weld tool, and let's jog in reorient position, reorient mode. So let's, when we jog in reorient mode, you have to see that the tip will go around the we can see clearly from this angle. So if you see, the tip of the robot is always in the same position. We can go around the point, so that means we can reorient the end effector. So this is how we add the TCP and we jog using the tool. So basically, like I already told you, we use the tool when we define any new targets for the robot. So if let's say if we have to replace the end effector, we don't need to teach all the points to the robot again, but we can just change the tool using the TCP. So for the practice session, I would like you to add the TCP for one of the end effector. You can use the same end effector, and please submit the video by jogging it in reorient like I showed you here. So your video should move your robot around the propeller point.